Greetings, mathies. We're looking at problem solving with trigonometry. And these are my helpful steps to follow along if you want to try to do them step by step. Sketching it is a really big way to just help turn the numbers into something that you can understand. So do sketch. Even if there is a sketch, maybe make your own. Sometimes that helps a lot. Show me where the unknown angles and lengths are, and then find the 90 degrees sections. Maybe they're marked, maybe they're not, but we can only do SOHCAHTOA, right triangle trig, with a right triangle. See if you can figure out some sides, right, opposite a hypotenuse, decide which sine, cosine, and tangent, which of the trig functions you're going to use, make an equation and solve, and then just like any good application problem, write your solution out as a sentence. For example, this starts life as a sentence, so you should leave it as a sentence. Let's try it together. A-frame house has a shape of an isosceles triangle. Isosceles means this side and this side are equal. They even write that out. These two little bits mean that those two sides are the same. And here are some helpful hints about other geometric interests with an isosceles triangle, rectangles, rhombuses, etc. You might maybe want to sketch those down. The oblique walls of the building are 12 meters long. Oblique because it means sides. Okay, so how wide is it at ground level here? Fine, that's fine. Yes, it has a pretty picture. So let's sketch it without the pretty picture. Well, that's terrible. Maybe I can do a better job with some help. Like that. Okay, so there's my triangle. I know that this is 12 and this is 12, and these are 70 degree angles. Maybe I can't do a better job. I don't see a right angle in there, but if we drop a vertical line there, I bet we could break this into a smaller right triangle. Right? So a lot of this comes down to the geometry and breaking this up, trying to find the 90 degrees. So this is 90, this is 70. Sorry, writing with my finger. And this is 12. We got ourselves a ball game. Now we're interested in this side. This side, let's call it an X, right? And so we're interested in the adjacent. This is adjacent to the 70, and the hypotenuse. So adjacent hypotenuse sounds like cosine. So you'd say the cosine of 70 is really equal to the adjacent X over the hypotenuse 12. And so on your calculator, you'd say cosine of 70. Oh, I'm getting 0.34. So this is 0.34, and then you multiply by 12. 0.34. Multiply by 12 to get rid of the 12 on this side. Effectively, you're doing this times 12. These cancel out. And then you're saying times 12 on that side. And so I got 0.34 times 12, which is 4.1 is X. So this length is it's not 4.1, right? Because this is 4.1. You got another 4.1 there, so you got to add them, right? And so 8.2. So then you would say, maybe I'll write it out. The building is 8.2 meters wide. Yo. Neat. Let's check it. Neat. How accurate do you need to be on rounding? Use some context. If you're talking about meters, 0.2 meters and 0.21 meters, 0.01 meters is a centimeter. So you could probably measure to that. So maybe 0.21. Okay. All right. Maybe you try this one and then pause me and come back to it. Pause. Oh, that's the animal kind of pause. P-A-U-S-E. Okay, let's try this out. Staircase, blah, blah, blah. This is the actual length, not the height. You need the 2-axis platform this high, find the angle. Cool. So again, let's build our own little triangle. Here's the 90-degree angle. Let's excise it. I have exercised the demons. Here's 3.9. It's 3.6. Sorry. Here's 2.9. Now we got to figure out which angle they want. Angle makes with the ground. Here's the ground, so we want this angle. All right. So let's call that theta. Now, in relation to theta, this is the opposite side, and this is the hypotenuse. So that sounds like sine. Sine in class. Sin out of class. Sine is the opposite, that 3.6. No, it's 2.89. Sine of theta is 2.9 over the 3.6. I did it again. And if you divide those, say 2.9 over 3.6, we get a gross decimal. We get 0.805555555555. That's the sine of theta. But it's not the angle itself, so you have to take the inverse of both sides to get theta. So you'd say, effectively, you're saying inverse sine of the sine of theta, and that just gives you theta. And then you take the inverse sine of the other side too. Inverse sine, all right, of that mess. So on your calculator, you'd say second sine 0.805555, something like that. All right, and I got 53.6. 53.6 degrees. There's another way to measure angles called radians. We'll get to it. Okay, so we got A, and we're going to get to B. The distance of the foot of the staircase from the post supporting it. The distance of the foot of the staircase from the post. Oh, that's easy enough. That's just this side. I'm going to steal this again. Same triangle. We're just looking for this length, x. Now, we have a lot of information here. We have these angles. One way to do it is, for little kids and old ladies, you can say a squared plus b squared equals c squared, and use Pythagorean theorem. Right? You can say 2.9 squared plus x squared equals 3.6 squared. Sorry, this doesn't look like a 3. Right? And you can say, you could square this, square that. Well, let's do it now. Okay, so let's go 3.6 squared minus 2.9 squared, 4.55, and then take the square root. Take the square root of 4.55, and I'm getting 2.13. Alternately, for real mathematicians, or people that just want to flex, you could also use some trig. So there's method 1. We know this angle. This angle is 54, 53.99, whatever it is. So we could say, maybe let's use this and this. We could say the cosine of 54, 53.199, whatever it is, should be the adjacent over the hypotenuse. And so I'm going to go cosine of 54. I get 0.587, 0.587 equals x over 3.6, and then multiply both sides by 3.6. Guess what you get? I got 2.12. Same. Oh, I rooted that. Sorry, so x was just that. Apologies. Similarly, why did you do that? You could, if you pretended you didn't know this, you could use this side and this side, and you could say tangent is opposite over adjacent. So you could say tangent of 54 is really the opposite, 2.9, over the adjacent x. This one is worth trying to solve on your own because the denominator is the x. It's a little bit fussier, so you'd have to multiply the x to both sides. Cancels out of there, and then so you're left with x tangent of 54 equals 2.9. So effectively you're left with this. And then from there you'd have to divide the tangent, both sides by the tangent. So you go divided by tangent 54, or the gross decimal if you like working with gross decimals. Just pop it right in there. It's 4. Sorry about my terrible finger writing. And this side you'd have to, this side you'd also have to do the same thing, divided by tangent of 54. Whatever gross decimal with the tangent of 54 is, divides out on both sides. Out the left side like that, and you're just left with x. Shazam! And then when you say 2.9 divided by tangent of 54, close your parentheses. I got 1.011. Sorry, 2.11, which is the same as those. All of those would be acceptable answers, right? There's a little bit of rounding error, but then you would say for both of those, you would say as your answer, for A, the angle, capitalize, what are we, heathens? The angle the staircase makes with the ground is, what did we say, 53.6, who cares, degrees. B, furthermore, the distance of the foot from the support is, what do we say, 2.13 meters. Yo. Right? You don't have to write that completely out. Shorthand, you'd say the angle is 53 degrees. The distance is 2.13 meters. That's the minimum, right? Cool. So use your trig prowess and try 13E. And if you want to go on after that, you are welcome to. Hope that helps. See you later.